Hello, everyone, and thank you for joining this evening. We have a GMAT free prep hour tonight on a very exciting topic. I think that we're all going to have a really good time. And by we all, I mean I'm going to have a really good time, and you guys are hopefully going to learn some things. Hopefully you have fun too, though, because I tell all of my students this. I'm going to keep saying it until the end of time. One great way to do well in the GMAT is truly to have fun with it, or at least not to hate it, right? If you hate something, tendency is good that you're not going to do as well at that thing. So what you want to do is try to find a way that you can enjoy it. You're learning a lot. So that's one good way. In chat, I would love it if everyone could just start introducing themselves. Let me know where you're located. That's always fun on virtual events because people jump in from all over the place, which is awesome. As you do, Oakland, California, that is awesome. I am calling in, by the way, from Ann Arbor, Michigan. I was located in Southern California for a while, a few beautiful brief years. Now back in the Midwest and buying a parka for winter. Excellent. Oh, we got someone from Peru. That is really awesome. You all know, obviously, about the free GMAT prep hours that we offer because you're here. However, we do have some other free options, and I wanted to make sure that you are aware of. First off, you can try a free live GMAT class if you'd like. I'll let you know at the end of the class here about a session that I have coming up. It's on September 20th. The first class session of all of our live classes is always offered as an option to join for free. And we truly do cover content in those sessions. It's not just a kind of fluff first session. So you'll learn about data sufficiency and sentence correction mostly, but a lot of other really good like testing strategies and things. You also can get a free Interact trial, which is our on-demand course. And that is extremely helpful in studying as well. There are a host of other things, so go to this website to learn more, the GMAT/resources, and you can figure out some other things that are very helpful. Oh my gosh, we've got people from all over the place. I'm still seeing them roll in from Canada, from Texas, from Florida. This is really exciting. What we are covering tonight is equally or more exciting. I don't know which. We're covering data sufficiency. We'll be talking about that quite a bit. But we're also talking about it in the context of number properties. And in my classes, I get a lot of people who really just don't like number properties. But I think that it's because it feels kind of ethereal sometimes. It's a not very well defined thing in their minds. And so they feel a little bit overwhelmed by it. Data sufficiency is something that hopefully you are aware of at this point. Basically, your goal in data sufficiency problems in the quant section is to ascertain whether there is enough information that you could solve the problem. In parentheses here, I have said, may not need to fully solve. Ideally, you're not fully solving. That's one sort of mistake, I guess, that people make with data sufficiency. You can spend a lot of time actually getting to a solution, but you don't always need to. And on the GMAT, your primary goal is to use your time wisely. Now, I know a lot of you are thinking, yeah, but my goal is to get problems right. It's to get questions right, get a great score. Yes, but only through using your time wisely. You need to forget all of those other goals that you have and really think about your time and whether you are putting your time and energy into the problems that you can solve and skipping the ones that you can't. Number properties then are really the attributes, qualities, and characteristics of numbers. So I'm going to give you a quick example here to show exactly what this looks like. All right, we've got a number here, obviously. We've got 36. What are some qualities of the number 36? If we're thinking of qualities of 36, how could you describe this number? What characteristics does it have? Yeah, I'm seeing some people writing in chat even. Definitely, we've got even. Oh my gosh. I'm seeing some other really great answers here. I see perfect square. Awesome. Yes. Factor of 3. Ooh, close. It's a multiple of 3. We're going to look at a difference between multiple and factors here in just a second. It is divisible by 3. It is divisible by 2. Absolutely. So it's positive, it's even. Positive is something that I haven't seen anyone say yet, but it's something that we kind of forget about, right? Positives versus negatives. The GMAT loves to test that, and it loves to get you tripped up and assuming that something is positive when it's not. Even, it is a multiple of all of these numbers. It is a factor of 72. So a multiple of a number is, it's getting bigger, right? Factor is, you know what, actually, a factor is a smaller number that goes into a larger number. So if you multiply 2, then you can get to 36, but 36 is a factor of 72. It's also not a prime number, 36. Prime numbers are definitely something that come up as being tested in number properties as well. And then finally, perfect square, which somebody has already said. Now, this is not the way that you're going to see number properties tested, but here are some more examples of how this might come up, the types of different pieces of information that arise. What becomes really difficult is that this is tested in really devious ways, which we're going to look at in some problems. These are all things that you should know, though. If anything on this slide is news to you, the number properties is definitely something that you want to shore up. So taking a look at the first one, what are the factors of 20? All of these numbers that go into 20. Don't forget that 1 and 20 are factors of 20. That is also something that I have seen tested on GMAT official guide test problems. What are the 6 smallest non-negative multiples of 3? Oof, we've got a real challenger in this one. We've got 0. 0 is in fact a multiple of every number. That's something that may come up. 0 and 1 are numbers that we just kind of forget about sometimes, right? It's we know they're numbers, we know they exist, but if somebody asks you for a multiple of something or a factor of something, 1 isn't something that jumps into your mind. The GMAT definitely tests that. The GMAT test writers love to test you on things that they already know that you're going to forget. That was something that was a personal struggle for me, actually, when studying for the GMAT and preparing to take the test. I forgot about 0 and 1 so frequently that I just started writing 0 and 1 down on a note card before I took a cat. Every cat, I would just write down 0 and 1 to remind myself that they existed. The 6 smallest non-negative even numbers. 0 is technically an even number. Yep, absolutely. Another surprise in there. Again, something that is probably going to be tested, right, at some point. 6 smallest non-negative odd numbers. Not many surprises in there. All right, first 6 prime numbers. Can anyone tell me what the first prime number is in chat? What's the smallest prime number? Oh my gosh. I'm seeing a string of 2s and I am loving it. You are all right, absolutely. This is something that's definitely tested. I see this come up in problems here and there. All right, and then this here, the remainder of 5 divided by 2. What's the remainder of 5 divided by 2? Oof, you guys are on it tonight, and I like it. I like it. Since everyone got that, you're all saying 1, which is correct. Can anyone tell me what the remainder is of 2 divided by 5? Oh my gosh. Absolutely. 2 divided by 5 is technically 0, remainder 2. Also something that can be tested, okay? Wow, you're all doing great tonight. So I think that we're ready to jump into a problem here, and it's gonna be an exciting one. All right, I always recommend that before you take a practice problem, you take just a moment and really take a deep breath, clear all of your emotional energy. That's a really good practice on the official exam as well, especially if you're experiencing high testing anxiety. I'm not somebody who tends to experience high testing anxiety, but I tend to get into this rhythm where I'm like moving too quickly, right? I can feel that my energy's building. I stop, I take a deep breath, and it reminds me to stay grounded and to make sure that I focus on what matters, which is using my time wisely. All right, take one more deep breath. You're gonna have 2 minutes on this next problem. And your time starts now. All right, that is 2 minutes. I'm seeing in chat a comment that says, I see. Can you give me more information about what you see? I'm curious about that comment. Ah, excellent. What's really great about this comment here is, yeah, I'm just reading this chat. What's really great about this comment is that when you're looking at a problem, first off, there's this tendency to kind of give yourself a pat on the back if you get a problem right? We all do it. I do it. I've done it. Getting a problem right in practice isn't always necessarily your goal. Your goal is to approach a problem correctly and to solve it in a way that serves you for future problems. So if you miss a problem, but you learn something, that is so much more valuable than getting the problem right. The other thing that brings up for me is that when you do miss a problem, the best thing to do isn't necessarily to go and to read the problem explanation. What's really good is to just take a look at what the correct answer is. If you look at just the letter answer and then think to yourself, wait a minute, why did I get a different answer? Why is this the correct answer? You're forcing your own brain to do that work, which is so valuable, right? Rather than just reading through the description of the problem and seeing why the answer must be what it is. Excellent, yeah. All right, so we're gonna break this one down. I think this is a fun one. I had a good time with it. Oh. We're looking at if X, Y, and Z are prime numbers. I love to see that, prime numbers. Why do I love to see it? Because my first goal in any GMAT problem really is to understand what's being tested. I know that I have an advantage if I know what's being tested. I'm like, I know what tricks these GMAT test writers have up their sleeves. If I can figure out what they're testing, that gives me the upper hand. All right, so we've got X, Y is even, X, Z is even. First off, I'm seeing that these two statements are really, really similar to one another, which gives me pause, right? I'm like, but why? Why are they so similar? There has to be something in that. We know that X, Y, and Z are prime numbers, and X is less than Y is less than Z. So we're trying to figure out what is the value of X. So this is clearly a value problem. We need X to have one specific value in order for either of these statements to be sufficient. So if we can get multiple values for X, not sufficient. Looking at this, I see that X, Y is even. Now, earlier we talked about the smallest prime number being 2, right? When I see X, Y, and Z are prime numbers, by the way, I'm automatically thinking, great, well, what are some prime numbers? I'm listing them off, right? I'm trying to come up with some examples here. This is a helpful exercise in problems because sometimes it gets you thinking about things that you wouldn't otherwise think about. It took me like a few seconds too, didn't take a lot of time. All right, so X, Y is even. I know based on this list that I just made and thinking logically that most prime numbers are going to be odd, all prime numbers except 2, in fact, because if they were even, 2 would go into them and they would no longer be a prime number. Because 2 is the only prime number that is even, 2 must be one of these numbers, X or Y. Now, I saw that comment about I see. I thought it was C, and now I see the answer is D, and D is in fact the correct answer. I won't leave you all in suspense. Yeah, we know that 2 has to be in here, and then we don't know what the other number is, and we don't care. X has to be 2. Why? Why? Why does X have to be 2? Because X is less than Y is less than Z, which means that X must be our smallest prime number, and 2 is the smallest prime number. Y can't be a prime number that is smaller than 2. So in this case, we know that X must be 2. We really don't care what Y is. Y can be anything. It could be 3, it could be 5, it could be some enormous prime number with 4 or 5 digits. It just doesn't matter at this point. So statement 1 is sufficient because we have one specific value. Statement 2 XZ is even, oof, really similar. We know that because it's even, 2 has to be in the mix. X is less than Z, so X has to be 2. Z cannot be 2. Statement 2, also sufficient because it gives us one specific value that X must be, all right? I started with statement 1, so this is the little answer grid that we would typically use. Looking at statement 1, I found it to be sufficient, so I would cross off the second row, and then I would cross off A, and I would choose D here. If you have not used these answer grids from Manhattan Prep, I would recommend that you go and look that up because they're extremely helpful in keeping track of which answers you are eliminating. Oh my gosh, I love this. I'm seeing in chat some takeaways here. How did you start using takeaways? Is that something that you started doing on your own or something that you've seen from other Manhattan Prep materials? I ask because it's a very Manhattan Preppy thing to talk about. So Manhattan Preppy, in fact, that I have a whole slide of takeaways. Yeah, can I explain what option 2 meant by together? Yeah, absolutely, for sure. So looking at your answer choices here, thank you so much for asking, by the way. In chat here, I have the question, can you explain what option 2 meant together? If you are a little bit newer to data sufficiency, or even if you've been doing it for a while and you just need a reminder, what these answer choices mean are, A is statement 1 is sufficient by itself. B, statement 2 is sufficient by itself. C, you need both of them together in order to be sufficient. D is either of the statements are sufficient. So in that case, in the case of this problem here, the answer is D because either one of them by themselves are sufficient. And then E is you just don't have enough information. So even when you look at one statement, when you look at the second statement, when you combine them, there's just not enough information all around. Did that help? Oh, okay, perfect. Takeaways. Why is it important to have takeaways? Takeaways are amazing because you're never going to see that problem again. You're just not, I mean, unless you screenshotted it and then, or look at this YouTube video in the future, that's not a problem that's going to come up for you on the official test for sure, right? So why do we do practice problems at all? We do practice problems so that you can be prepared for a problem that kind of looks like that one, right? Or makes you think like that one. So takeaways should be things that are really actionable for you and things that make you better on future problems. Now, I always like to think of recognizing as a particular takeaway. If you don't recognize when number properties problems come up, you can't be successful on them. You'll just do some guesswork, or you'll get yourself involved in some weird algebra or something that you just don't want to get involved with, right? So how did we recognize that that was a number properties problem? First, we saw prime numbers. Ooh, that's a dead giveaway. And then we saw even. The product of two numbers was even. Both of those are really strong clues that it was a number properties problem. How did we solve? Well, really, we kind of tested cases, right? We looked at X and Y and we said, well, if their outcome is even, then I have to have an even number, because if I'm multiplying them, I can't multiply two odd numbers to get an even outcome. That was sort of a testing cases approach, and that's often what you'll do with number properties problems, especially data sufficiency. You can sometimes test number types instead of specific numbers. So when we were thinking about X and Y and then X and Z, we were thinking about a couple of specific numbers potentially, or at least the number 2. Sometimes you can just think about like even times even or even times odd. And I usually represent that, instead of writing out the whole word, as like E. E plus E equals E. You will have a chance to see some examples of this coming up and how that works. Other important observations. 2 is a prime number. Very easy to forget that. The GMAT test writers know this. They are on it. They will test it. And there's very similar information given in statements 1 and 2. Looking at that, to me, this feels like it could potentially be a little bit of a C trap, right? You look at both of them and you're like, yeah, I could definitely figure out whether X is even by looking at both of these statements. If you look at two statements just right off the bat and think, yep, it has to be C, you should definitely spend a little bit more time on that problem. The answer might still be C, but it could be something else. All right, who's ready for another problem? I sure am. All right, take a deep breath. You're gonna have another 2 minutes on this one. Clear the air. This one problem is gone. It is behind you now. There's another opportunity ahead of you. What I would like you to think about for this problem is, how do you recognize that it's testing number properties, aside from me telling you that this is a number properties session? And what are you thinking about as you solve the problem? How can you organize your thinking in a way that helps you best solve it? All right, without further ado, your 2 minutes shall start right now. That is your 2 minutes. You know what's really fun here? I'm seeing all sorts of different answers coming through in chat. I love to see that because it shows that this is a good problem, right? It's a tough problem. It's not a problem that you can't solve, though. It's definitely something that's solvable. All right, let's take a look at this one. How do we know that this one is number properties? Let's dig into it a little bit and we'll see. Is PQR greater than 0? I'm going to rephrase this question in my mind. Instead of saying greater than 0, I think about this as, is it positive? And that is really how you know that this is testing number properties. When I glance at the statements too, I'm seeing PQ is greater than 0, it's positive. Q over R is less than 0, so it's negative. I'm seeing a mix of positives and negatives here, which means this problem is testing positives and negatives, which are properties of numbers, right? Knowing that, testing cases is a really good approach to take here. Can you solve this one without testing cases? I see that question in chat. You know what, there are so many ways to solve any given problem. I have been sitting in class sometimes with problems that I've seen several times and thought that I found every possible way to solve them, and a student will come to me with a way that they have used, and it'll be the 6th way, right? I have 5 others and this is number 6. I'm sure that there is a way out there. Solving this one using testing cases is a really good approach, though. I would say that when you're thinking about all of the different ways to solve problems, you're not looking for just like all of the ways that exist. You're looking for what is the best use of your time. How can you know immediately what to set up? so that it doesn't take a lot of effort and energy to think of that method. And what's something that you can feel really confident about, in the moment, right? Because you're going to have a lot of adrenaline, you're going to be promptly stressed out when you're taking the official test. You want something that's like tried and true. All right, so looking at this one, there's not really just one good place to start, right? The statements look pretty similar to one another. Sometimes when that's the case, I start with statement 2, just because the test writers hide things in statement 2 sometimes. If the statements are pretty similar and statement 1 is not sufficient, we're more likely to think that statement 2 is also not sufficient, and sometimes it is. So that can be just a little bit dangerous if you're not careful. In this case, I started with statement 1 just because. I also always start with something that I know when I'm testing cases. So I like to set myself up a really good testing cases table. You may ask yourself, but how do I do that on the test? How do I do it in the moment? Set up a great table. You do it by practicing it, honestly. I had to get really good at making good tables. This was not something that came naturally to me. I didn't like doing it. I taught myself to do it because it's super organized, and missing a problem because your work wasn't organized is a really tough way to miss a problem. It just doesn't feel good. So looking at this, I start with what I know. PQ is greater than 0. That is what I know. That means that PQ must be positive. And this is the example that I was talking about earlier, where sometimes you can test cases just by saying like positive, negative, or even odd. All right, if PQ must be positive, then the simplest case that I can think of is that P and Q are both positive, right? So if I multiply positive 2 times positive 2, for example, I get positive 4. Positive times positive is a positive. That's great. Now, if I say that P and Q are both positive, do I know whether PQR is greater than 0? Waiting for chats. Do I know? Is PQR greater than 0? Yeah, I have no idea, right? What about R? I'm missing information about R here. Yes, if R is positive. No, if R is negative. Right? I don't know anything about this. Absolutely, I just saw in chat. I can't stop here. There's another case I need to test. PQ, the outcome could be positive because P and Q are also both negative. Looking at this, or R could be 0. Yeah, excellent point. Yeah. See, here I am, not even thinking about 0 still. Jeez, come on, Tiff. I'm better than this. Yeah, but if we look at P and Q as being negative here, we still don't know what PQR is because we still don't know anything about R, right? We're like, well, I mean, could this be greater than 0? Yes, if R is positive again, right? Yes, if R positive, no, if R is negative. It's the same situation as before, and if I'm sitting and thinking about it, I just don't have any more cases I can test here because PQ has to be greater than 0. I underlined it here, which I would typically do on the official test even, because this is something that I cannot violate. It is the statement, it is true, I have to believe that it is true. All right, so statement 1 here is not sufficient. I'm using my little table again, my little answer grid. That's the worst A, what a weird A, come on. And then I'm moving on to the next statement. I love to prove statements not sufficient, by the way, because it's really hard to prove a statement sufficient. There are not a lot of cases that you can really prove that it's sufficient, but dang it, you can prove that it's not sufficient. That's really ultimately your goal for data sufficiency. So I said this last session was a little bit about data sufficiency, and it is. We're seeing a lot of DS problems, right? You want to keep in mind when doing DS, try to prove that it's not sufficient. If you can't, then you just assume that it is sufficient. All right, Q over R is less than 0. So this is negative, right? We have a negative outcome. Yeah, I'm seeing in chat, you can't get a negative number by dividing two positive integers. So over here, that brings up a really good GMAT shorthand or GMAT code, if you want to think about it like that. P times Q is greater than 0. What does that really mean? P and Q have the same sign. That's what that means, right, in GMAT speak. The GMAT test writers are hiding it. It's like their own private secret code, but that's what it means. So if I'm looking at this new statement that's different, a little bit different, and I see that Q over R is less than 0, then Q could be negative, right? But then R would have to be positive. Or other case is that Q could be positive and R could be negative. Really what this means though is that Q and R have opposite signs. So when you're thinking about just what kind of information are you getting from statements, you really want to boil it down and kind of put it in your own words usually, right? It's not just, oh great, I tested some cases and now I'm going to go test some more cases. It's what did I learn from testing those cases? Can I summarize that for myself? I got a question in chat. Can R be negative? Yeah, sure. Why not? R could be negative here. I have no idea if Q is larger than R. Yeah, we don't know, right? We don't know if Q is larger than R. R could be larger, Q could be larger. We don't really know anything in terms of like the order of magnitude of these numbers. Nor does it really matter too much, honestly, right? Because it's still a positive or negative number. So that's a good question. I'm going to take a second here. Like Q could be 1 and R could be 2. That's still a positive number. It's still greater than 0, right? We can't have that in this case. One of them has to be negative and one positive. So let's say Q is negative 1 and R. Great, that works out. Let's say Q is negative 3 and R is 2. Let me flip the negatives on this one actually. In this case, Q was larger than R, right? Q is negative 1, R was positive 2, so Q was larger. I can make Q is smaller. My gosh. Q less than R. There. Actually, this is a really good teachable moment. On the GMAT, if you're doing a bunch of thinking in your head about things, that's not a good place to do your thinking. You should do your thinking on paper so that you don't get yourself confused, like I just did. All right, over here, Q is, finish one thought at a time, Tiff. This is still less than 0. Q is larger than R in this case because Q is positive and R is negative. Ultimately, though, it doesn't really matter about the order of magnitude of the number specifically for this particular problem. All we really care about are the signs. I know that because I've seen problems like this before. So I know that testing signs like this as positives and negatives is really the goal. It's not to figure out specific numbers that I could plug in. You could do it that way. You could test cases like that. It's just slower because you're going to ask yourself questions like this about, well, what's bigger, Q or R? And then you're going to end up testing probably more cases than you need to. All right. We don't have our answer here yet. We know they have to have opposite signs. Do we know what PQR is? Do we know if it's greater than 0? In chat, I'm looking for answers. Do we know? I'm waiting just another moment. Do we know? Got some conflicting. Yeah, we don't know anything about P. Thank you. Okay, I see this comment is perfect here. We don't know anything about P. We feel like we know something about P because we just finished statement 1 and we learned something about P, but we need to forget statement 1. It never happened to us. We're evaluating statement 2 now. We don't know anything about P. Here, we have a situation where PQR could be greater than 0. Yes, if P is what? PQR is greater than 0 if P is if P is negative. Why does P have to be negative? Because we already have one negative. We have one negative. I need a negative times a negative to equal a positive. So in that instance, it would be P as a negative, Q as a negative. Great, that's a positive. R is positive as well, right here. But PQR is not greater than 0 if P is positive. This flip here, yes, negative, no, positive. The test writers did that on purpose here, right? Because we want to pair yes, positive, no, negative mentally. So definitely this feels like something intentional that they did. I mean, I didn't talk to them about it, but feels intentional. All right, here we also have a really similar situation. We still don't know anything about P. Ultimately, it's going to be the same information as above. We still need P to be negative because R is negative in this case. So we still need to multiply by another negative to have a positive. B is not the correct answer. A and D are not the correct answers. We're only looking at C and E left. So now we have to combine statements. And this, my friends, is where practicing making good tables is such a game changer. All right, this is the table that I would make. So I would set up another little table to test cases. And I would only do this, by the way, if I'm less than like 3 minutes into this problem. I'm not going to tank all of my time on one problem if I've already spent a bunch of time on it. So at this point, if I'm choosing between C and E, and I have spent 3 or more minutes on this problem, 3 minutes is my cutoff. I should not be going over that. I'm going to make an educated guess and I'm going to move on. If, because I'm good at making tables, if I've been efficient enough that I have a little extra time to play with, then I'll set this table up and I'll test both of the statements together. All right, again, I'm going to look at signs only. I'm going to start with P because it's like the most kind of constraining, I guess. It's just a good starting point. And I've set this up and I know that because I know that Q has to be the same as P and R has to be the opposite of Q. I know this because of what the statements told me. The only reason I've made this table is because I've gotten good at interpreting what the statements tell me. So that truly is a solid GMAT skill to have in your back pocket. All right, so if P is positive, Q has to be the same as P, so Q has to be positive. R has to be the opposite of Q, so R has to be negative. Is PQR greater than 0? Nope. I got a question in chat. If you take 3 minutes but get the problem correct, is it a good use of time? That is such a rock solid question. It depends on what you're doing with the rest of your time. And it depends on how difficult the problem is. So if you are struggling with time throughout the section, you're either ending with too much time left or you're ending with running out of time essentially for the last few problems, then timing is something that you need to work on and pay attention to. Yeah, you're running out of time. Okay. 3 minutes is my cutoff. You can spend 3 minutes on a problem. If it's a really difficult problem, you might want to consider bailing before the 3 minute point. And I say that because easier problems you need to get right. Those hurt your score if you miss them more than missing hard problems. Those easy problems, it's like you're building yourself a solid foundation. The GMAT's like, can you handle this? Okay, great. Let's go up a notch then. It gives you more difficult problems then. If you miss an easy problem, hurts your score. Missing really difficult problems doesn't hurt your score a whole lot, honestly. Those are the ones that you really want to aim to miss. And I would hesitate to guess that some of them you're getting right at 3 minutes. Some of them you're probably spending more than 3 minutes on. That is the thing to caution yourself on, right? If you get used to spending that much time, 3 minutes, for example, 4 doesn't feel, 3.5, 4, that doesn't feel like that much. but you're kind of stealing that time from other problems. So an extra 30 seconds or a minute past that is like half of another problem, a quarter or a half, right? Got to kind of think about it like weighing that. What does it mean for the rest of your section? No one problem is going to get you to the score that you want. Every new problem is a new opportunity. I'm going to make a GMAT inspirational quotes calendar. All right, so the other alternative here obviously is that P could be negative. In that case, Q must be negative because it's the same as P. R is the opposite of Q, so it would have to be positive. Is PQR greater than 0? Yes. Oof. I got a yes answer and a no answer. I don't know the answer to this question, right? Sometimes PQR is greater than 0. Sometimes it is not. So my correct answer here is E. Yeah, that's a good statement in the chat here. We don't know enough about P. If I had some more, if only I had more information about P. This is a good outcome though for a problem, right? You get to this point and you can definitively prove that it is not sufficient, which feels really good. You can feel really confident in this answer versus saying that something is sufficient, because again, you can't prove sometimes that it is sufficient. There are always more cases out there to test. All right, man, that one's fun. Okay. I told you we're all about takeaways, and we are all about takeaways. I'd say that was like a moderate problem. And it's not about, what's interesting about number properties, and a lot of different problems, honestly, on the GMAT, is that it's not hard because the math is hard, right? Looking at this, like, you know, or you can figure out that two positive numbers multiplied together are greater than 0. You know that two negative numbers multiplied together are greater than 0. You can know some of those basic pieces of fundamental information, but if you don't know how to interpret what a statement is telling you, and if you don't know how to organize your work effectively, if you don't know what cases to set up, those are all other skills that are equally important to understanding that fundamental information. How do we know that it's testing number properties? They're inequalities. When you think inequalities, when you see inequalities, you think it's testing positives, negatives immediately. That's what you think to yourself. Inequalities, positive, negative. Let the statement or let the problem prove otherwise to you if it's testing something else. It's almost always positives, negatives. Solution method, again, is testing cases. That's really the best approach here still. And then really using those plus minus placeholders instead of real numbers. We would have tested so many more cases if we had used real numbers. Other important observations, this feels like a C-trap to me. Looking at both of those, I'm like, oh yeah, I got P and Q relationship, I got Q and R relationship. I can do something with this, that feels good. You have to look deeper to figure out that actually the answer is E. And then start with what you know when testing cases. People are very tempted to start setting up P and Q first. It's more, when you do it that way, it's more tempting to accidentally violate the statement. If you put what you know first, you're set up for success better. All right, we've got another problem. Take another very deep cleansing breath. Get excited about this next one. And let this one go. Again, it's great if you miss problems because you have an opportunity to learn from that. You just have to take that opportunity. If you get really good about recording your takeaways in particular, that can be extremely helpful. So I strongly recommend that you start keeping an error log or a review log if you're not already. That is somewhere that you will record problems that you have attempted and where you found them. You will write whether you got them correct or incorrect, and then you will write a takeaway, just one or two key takeaways. What would you change about your approach to that problem or to a similar problem if you saw it again? And then write down a due date for yourself. retake that problem, reattempt it in about 2 to 3 weeks. You'll have forgotten the details, but if you learned the takeaway, then you should be able to get that problem correct. Yeah, that one was a moderate difficulty problem. We're going to get into some slightly more difficult problems here. More difficult on the GMAT, though, doesn't mean harder math. Again, it means harder thinking most of the time. Or it means like combining different concepts. So you need to understand several different things to be successful. Oh, that's worse? No. I know you guys have been studying. You guys can think. You can all train yourselves to think successfully like the GMAT test writers, right? All right. Take a deep breath. You're gonna have 2 minutes and we're gonna enjoy them, these glorious 2 minutes. All right, your time is starting now. Hello, hello. 2 minutes is over. Did you have fun? It's a real answer. It's a real question. I try to have so much fun on the GMAT. It's kind of like when my student said, you know, the GMAT's kind of like a game. It's like a riddle. And I was like, oh yeah, you get it. You're getting it now. All right, how do we know that this is testing number properties? In chat, tell me. How do we know? Yes, even. I also like that you said integers. Sometimes when they tell us that things are integers, that's a sign, right? It's like, usually they don't tell us that certain numbers are integers. And so we're like, great. So I have to think about all the cases that they might be fractions. And that presents its own set of challenges. It's a little bit easier if they say that the numbers are integers, which tells you something about what's being tested. It doesn't always mean number properties, but it always tells you something important. So when they say that certain numbers are integers, definitely pay attention to that. Is X even? Excellent, excellent. All right, taking a look at this one. They look pretty similar to me, so I'm going to start with statement 2 this time because I can't start all of these with statement 1. That's just going to demonstrate to all of you that you should always start with statement 1, and that's just not the case. I can't set that precedent. All right, taking a look at this one is a number properties problem, but you also have to understand rules of exponents, right? So this is a great example of combination skills being tested. I always rewrite the problem, by the way. Like always, literally always. It forces me to understand the question better. I rewrite the question, is what I meant to say. It also means that I've rewritten it in a way that's like shorthand for me, and that's going to be easier to refer back to if I forget what the question is, which is possible and happens to a lot of people. All right, so statement 2 here, I'm already seeing a pattern. Patterns are also very prevalent on the GMAT, just noticing things that jump out at you, right? Like, ooh, I see 3, I see 27. 27 is a multiple of 3. What's happening there? Looking at this, I have 3 to the x plus 5. I kind of want to get these into like terms because I like that pattern. And this is where you really need to understand the rules, right? So this is 3 cubed, and that's going to be to the y plus 1. So I'm rewriting it with parentheses first so that I don't miss any steps. And I truly would write it out like this on the official exam as well. I try not to make any silly math errors because I'm extremely prone to making math errors if I don't write things out. Why am I prone to making math errors? Because I am a human. Most people that I have noticed, if they don't write things down, are liable to make mistakes. So I really, really try not to do that. All right, 3 to the x plus 5 equals, when you have it inside parentheses like this, you're going to carry that through. So you get 3y plus 1. Now that I have the same base, I know that x plus 5 has to equal 3y plus 1. I can do a little bit more simple. Sorry, 3y plus 3. Thank you. You caught it too. Good job. I'll tell you what, thinking and writing, hazardous. And talking. Thinking, writing, talking. Those 3 things together. All right. So I'll subtract 3 from both sides. X plus 2 equals 3y. Oh, did you have that error too? Nice. See, if you don't write things out, even if you do write things out sometimes, but you're not going to be talking out loud during the exam, so that will help you. All right, x plus 2 equals 3y. Do we know if x is even from this information? Can we say definitively that x is even or not even? Getting a couple of no's and a yes. The answer is no here because we don't really know anything about y. So if we take a look at y, let's say that y is 2, for example, right? If y is 2, then x plus 2 would be 6. However, if y equals 3, for example, then x plus 2 equals 9, right? In this case, x would be even. In this case, x would be odd. We can't have that. We need one definitive answer. So this one is not sufficient. All right, taking a look at statement 1 then. We've got some similar information, but a little bit different, I'm saying, because we've got z pulled into the mix here. I'm also noticing that we've got 10 on this side and we've got 4 and 5 on this side. I would love to do something similar to what I did on statement 2. Looks like it's a little bit trickier, but I'm seeing some patterns here with like evens and 5, and I know 5 goes into 10. So I'm going to play around with that. All right, so this is 2 squared to the y, and this is 5 to the z. That's looking really promising. Why? Because 2 times 5 is 10. So if I'm looking at 10 to the x, I can actually pull this apart, and I can say that this is 2 to the x times 5 to the x. How does this help me? This right here, my friends, this next step, this is where your GMAT brain gets stronger. All right, they always say that in Peloton. I was like, this is the moment that you're getting stronger. It's true. All right, so here we've got 2 to the x times 5 to the x equals 2 to the 2y, 5 to the z. What I know from this is that x equals 2y and x equals z. Do I know whether x is even? In chat. I'm waiting for a moment. I'm letting your brains think. This is important. Dang it. I'm seeing a mix of answers. All right, I do see someone said yes and then 2y. Why did you say yes and 2y? What does that mean? Why is 2y even? Yeah, you wrote 2y is even. You're correct. Absolutely. And here we have the answer. All right, this goes back to the information that we were given, right? We looked back up here and we were like, oh, great, all of them are integers. You cannot forget that fact. It is incredibly important. If they tell you that these numbers are integers, oof, remember it. Any integer multiplied by 2 is even. It does not matter what y is. X has to be even because it is equal to 2y. Statement 1 in this case is going to be sufficient, and our answer is A. That is a GMAT move right there. So this is the moment that you had to combine skills. You had to think about number properties, but you also had to think about the properties of exponents and how they work. And then you had to make an inference based on that. That was a very, very strong number properties inference here. And that's how difficult problems become more and more difficult over time, right? They keep layering on new skills or new ways of looking at things until a problem requires you to combine several different things in ways that you haven't before, unless you have been practicing exactly that method of thinking. All right, can y be negative? Yeah, do we know if these are positive or negative integers? That's a great question. We know that they're integers. We don't know if they're positive or negative, no. In this particular problem, I don't see any questions about positives or negatives. So ultimately for this one, it doesn't matter. And I know that the question is x even? And that's really the important piece here, right? We're looking at evens and odds. That's what's being tested. And number properties more generally as well. I see this question, how are you able to split it apart? Are you talking about 10 to the x? How are we able to split apart 10 to the x? Going from the second line to the third and fourth. I see what you're saying. So moving from this second line, 2 to the x times 5 to the x equals 2 to the 2y times 5 to the z. I know that these numbers have to be equal. Like if I have 2 to the 5 times 5 to the 7, and then I have 2 and 5 as bases on the other side, I mean, this has to be a 5 and this has to be a 7 if they're going to be equal on both sides. Because I know that, I can say that x has to equal 2y and x has to equal z as well. The x equals z piece of information really doesn't give us anything to go on. It's like a nice to have, I guess, but here the real like focus is on this 2y. Yeah, exactly, because of the matching bases. Why do they have to be equal? Let's take a look at like 2 to the 2 and 3 to the 2, right? So this is an easy number to multiply out. 2 squared is 4 times 9, which equals 36. If I'm going to put 2 to the x over here and 3 to the y, I mean, X has to be 2 and Y has to be 2 as well. There's just no other way that this is going to work out so that these can be equal on both sides. If this is still something that is challenging for you, I would definitely recommend that you go and look at rules of exponents. That's basically what this boils down to, just like basic rules of exponents. If on one side you have the same base numbers as on the other side, then their exponents have to be equal in order to actually make the numbers equal on both sides. This is a more difficult problem, by the way. I would call this more difficult because of the combination of skills required in order to be successful. So when I say more difficult, it's going to be a higher level of difficulty than the previous problems that we looked at in terms of, like, you know, the 500, 600, 700 numbers. That doesn't mean that you can't get it right. And that doesn't mean that you can't get it right even more quickly and efficiently than easier problems. What it means is that you have to combine skills in a way that puts you at a higher testing ability than other people, essentially, right? Than like a certain percentage of other people. All right. Couldn't the question also be answered with both 1 and 2 together? If you get the answer that one statement is sufficient, you stop there. You don't combine both statements unless both of them, each of them, are not sufficient. So if I found statement 1 was not sufficient, statement 2 was not sufficient, then I would combine, but only then. Is there a certain number of hard questions you need to get right to obtain at least a 700 overall score? Oh, that is a really good question. No, there is no magic number. What you're going to see on the GMAT is where you end up is what you get. So let's say, I'm going to make a little graph. I'm going to call these like different difficulty levels. Okay, so 500 level, 600, 700. And then this is problem 1, this is problem 15, this is problem 31. We're going to call this the quant section. Let's say you end up, or you start off, sorry, getting questions around the 500 level, and you get a couple of those right. These circles that are filled in mean correct. You get them correct and you're doing so great. Oh no, you miss one. Uh-oh. Oh, you miss, oh no. Oh, that's okay, you get one right. You're gonna keep going back and forth like this, right? Your goal ideally would be to get as high as you can. And then you can keep missing, but then get right. Miss, get right. Like this is a super, super healthy trend to see right here. Very healthy. It means that that truly is where your ability level is, right? Like you're going to get some of them right, you're going to get some of them wrong. That's okay. That's great, in fact. What you don't want to see is you run out of time at the end of the section. Here you're heading out like maybe 650, 700 level, right? This person is. Let's say you run out of time at the end of a section though. Boom, boom, boom. Oh no, you're back to 500 level. Has nothing to do with your ability though. It has everything to do with your strategy throughout the section and your time management. You can set yourself up for difficulty early on in the section like this, but you have time to recover, right? I always recommend that you give yourself at least 2 minutes per problem on the quant section for the last 5 problems, because you don't want to see this trend for yourself, you know? You want to give yourself those full 2 minutes for the last 5 problems. So heading into problem number 26, you better have 10 minutes left in the section. Similar for verbal, right? You want to make sure that you have enough time to solve the last like 5 problems and really give them the time they deserve. You're going to miss a lot of problems no matter what. In the quant section, you're going to miss like probably 10 to 15. And on the verbal, 10 to 12 or 13 probably to get even a really good score, right? Now, those numbers aren't exact. You can miss more than that. You can miss far fewer than that, but you can still get over 700 if you're missing that number of problems. So it's not about missing a certain number of problems, it's about which problems you miss. If you miss one of these 700 level problems, it just doesn't hurt your score as much. Miss one of these 500 level problems, that's gonna hurt. That's not gonna be good. Usually the reason that people would miss lower level problems and get higher level problems correct is because they're rushing, by the way. You see an easy problem and you're like, great, I'll just fly through this one. You see an easy problem and you're like, I'm gonna slow down just a little bit and I'm gonna devote the time that this deserves in order to get it correct. Yeah, exactly. You want to be in control of your errors. Ultimately, you want to be the one who is deciding when you miss problems, right? You get to choose, I'm going to devote time to this problem because I know I can get it right. I know that I can do this, and it seems like an easy or a medium problem. I'm going to devote enough time to it. You see a problem and you go, yikes, this was really hard. Skip it. Who cares? You're probably not going to get it right anyway. You know, you might as well just bail on it early, reinvest the time in a problem that you can get right. Spread your errors out over the course of the section, not all in like a short period. All right, my friends, here are the takeaways from this problem. How do we know that that problem was number properties? The question was, is X even? Dead giveaway, number properties. Solution method, it was important here to recognize what was being tested. It gave us some additional information, but it was also really important to see this pattern in the base numbers and to recognize that we also needed to know the rules of exponents in order to be successful. More difficult problems tend to combine multiple skills like this. That's a trend that you will see. It's not always going to be about one thing, right? You see a geometry problem and maybe it has to do with something aside from geometry. You see linear graphs, sometimes those are hidden geometry problems. You need to be creative and think, how do I recognize what this problem is testing? Statement 2 here wasn't automatically not sufficient, by the way, just because Z wasn't mentioned. Some people look at that problem and think, oh my gosh, in statement 2, I didn't see anything about Z and that's a problem. Not necessarily, right? We found X was even just from information about Y in statement 1. So statement 2 could have been sufficient. It just wasn't. All right, I have one more piece of information to show you, which is my upcoming course. You can, of course, enroll if you would like. It starts on September 20th. This is somewhat of an accelerated course, not in terms of difficulty level, but just in terms of pace. We'll be meeting a couple of times a week. If you don't want to enroll, but you would like to spend some more time together, because it's fun, that session on September 20th is open as a free trial session if you would like to go and sign up. On the site, you're going to see it as live online fall F. So you can join session on September 20th as a free opportunity. We'll go through data sufficiency and sentence correction, which are really good skills to cover. All right. Thank you all for joining tonight. No, we went just a little bit over here because I just can't stop. I can't stop myself from talking about the GMAT. I hope that all of you enjoyed this and learned something from it. Please tune in for more free sessions as they come up, and good luck studying.